guys, in this video I'll tell you about how you can communicate between Raspberry Pi and Arduino over serial protocol. So from the last video we'll take our Raspberry Pi and Arduino Uno, and also we'll be needing a logic level shifter along with a breadboard and few jumper wires. Place the shifter on the breadboard like this and connect the low voltage side with the respective pins on the Raspberry Pi 0 to W, and similarly the high voltage side to the Arduino Uno. Just remember to flip the receive and transmit pins when connecting to the Arduino side to the pins 10 and 11. I'll be using a USB hub to connect them to my PC as I have only one port free at the moment. Moving on to the PC part, we need to do few things first before we get right into coding. Firstly, we need to SSH into our Pi from the command prompt using the following command: SSH followed by the username @ the host name which you have set during the setup of the microSD card from the video number 1. Enter the password and you will be successfully logged into the Pi 0 to W. After that, we need to install the serial package as we will be sending and receiving communication over the serial lines. For that, run the command sudo apt-get install python 3-serial. Wait for it to finish. Next, we need to check that if the serial is enabled on the hardware or not. For that, run the command ls-l/dev to list all the devices which are present, and in here search for the serial 0 device. For me it is present. If you do not see serial 0 device here, what we need to do then is to head into the config tool by using the command sudo raspi-config. Head to the interface option and select the serial port. Select no on the first and yes on the second prompts respectively. Now go back to the same lists of devices using the command ls-dev and it should be there. Now take a note of the address it is pointing to. We're gonna need it later. Now we need to make a folder using the command mkdir. Let's name it serial_test. Now what we do is that we move into that folder using the command cd space the name of that folder, and we make a Python file using the command sudo nano-blink.py. I'm not going to bore you with the coding part, but all the code will be given on our GitHub page. Feel free to explore our GitHub page later. One thing to note that while writing the code for the Raspberry Pi, you should be mentioning the address as /dev/ttys0. For me it is ttys0, for you it could be something completely else. Moving on to the coding part for the Arduino, here I'll be using software serial, as if you use the default serial pins which is pin 0 and pin 1, you need to unplug those pins every time you need to upload the code to the Arduino. So instead of doing that, we're gonna use pin 10 and 11 as RX and TX respectively. After doing all the coding part, here you can see that we are receiving messages on our serial monitor on the Arduino IDE. Now let's do one thing. Let's blink the onboard LED present on the Arduino Uno. Let me just copy over the blink code. There you go. You can see the LED is changing its state on every message received through the serial. Let me remove the serial cable and it should stop blinking. Yeah, it is. You can see it is now stopped blinking. Hence, now we can say that we are able to communicate from Raspberry Pi to the Arduino over the serial protocol. And this is it for this video, and I'll see you in the next one.